online, so we will, if you follow us on Twitter, we will tweet the link to it later if you want to look at it. So, what the hell is WebRTC? Does anybody know what it is or have heard about it before? Hands? Ah, so a lot. Has anybody done anything in it? Coded something? Okay, not so many. So, what is it? So in recent times it's been kind of hyped, I guess, as the next thing on the web, and there's a lot of tech blogs about it and a lot of different attention. Is it just for sort of video conferencing? Can you do other stuff with it? Is it just Skype sort of in the browser? Well, the truth of it is peer-to-peer networking in the browser. So this is the first time we've had full interoperability between browsers both on desktop and on mobile. It's very low latency. It doesn't require a server to send the data. It's truly peer-to-peer. You only need a signaling server for the initial connection. And it's without any pesky plugins, which is kind of a big deal, actually. So with WebRTC, you can send audio, video, and data. The data objects can be sent reliably and unreliably, so TCP and UDP. And you can send as large files as you want. Actually, any JavaScript object can be sent peer-to-peer between browsers once the connection has been established. And all this is possible right now on 1 billion devices. That's including mobile. So every Android smartphone with, I think it's 4.1, with Chrome installed, supports WebRTC as well, as of June. And the best part is, all of this comes at almost no cost to you as a developer. The only thing you need is a signaling server for the initial connection handshaking. After that, everything is just peer-to-peer between browsers, and nothing, well, in some cases you have to have a relay server, but almost nothing goes through the server. It's very, very cheap. So, what can you create with it? So, sort of when WebRTC started, it was built sort of around video conferencing, sending video and audio. And that's sort of what most guys have been developing right now, including us. But you can also do, once something called stream rebroadcasting lands in browsers, which it hasn't yet, you can do peer-to-peer streaming services. I don't know how many of you have watched bootleg football matches before, but they use sort of a Flash plugin where they sort of the server distributes to 10, then you distribute to 10 other peers. And the more people actually watching the stream, the better the stream gets, or you won't have lag at least. But that requires a plugin and sort of package, and with WebRTC you can actually do that in the browser without plugins. You can also do file sharing, peer-to-peer file sharing, or remote working office systems, or you can even build CDNs or telecoms entirely in the browser. So let's look at some of the different examples here. So the obvious one is what we've built, appearin. You just type appear.in/anything. It can be your name or the name of your company or anything else. Then you share that link over IM or vocally or your internal systems. And anyone that's, that clicks on that are in the room at the same time will chat to each other via video. So the image here is from a friend of mine. She lives in Trondheim. Since I'm now recently moved to Oslo, I really miss her. So we spend some evenings talking hours at a time, just hanging out, sending links now and then. It works great. There's no logins, no registration, no nothing. Entirely free. So, another application. This is ShareFest. It kind of solves the age-old problem of sending a file to another person. So it works on the same principle. You get a link, you send that to someone, then you upload your file, or actually you don't upload your file per se. You drag the file into the window and it's transmitted to the other peer without going through any servers. So that kind of solves the problem of, okay, I have my computer here, this guy has a computer in the same room. We don't have a USB stick. I need to move my presentation over there. Well, you just go here and you establish a connection via the Wi-Fi network. It doesn't go out at all. And you can transfer the file very quickly. But then you're probably thinking, okay, so if I can do peer-to-peer file transfers, can I build a torrent client in my browser? Well, yes. This guy called Feroz on GitHub, he's developing a JavaScript application that is actually a torrent client, a fully functional torrent client in your browser. No plugins, no nothing. It's not actually working yet because it doesn't have the stream rebroadcasting stuff that it needs. But according to the spec, it should work, and it's alpha, he has tested it and stuff. But that's also very exciting. Another thing that does work is this application here, Peer CDN. That's actually distributing the files, the static files for your page among the people that are actually visiting your page. So when another visitor comes in, they can download all the assets they need from the other guys that are visiting the page. So for example, for Start Scene, they have about 20,000 concurrent users, quite a lot. They could save a lot of data by just having peercdn.js and then letting the new visitors download files from that. And according to them, I haven't tested it myself, it should have about the same performance as downloading from the server. So that's really big, right? And there are other sort of corporates in the big corporate world that are starting to notice this as well. This is sponsors from a big event in the States, which was just now, WebRTC Expo. That's where all the big old guys, the telecom companies, come to talk about WebRTC because it's the new thing. And if you look at this, you have Ericsson, Plantronics, Alcatel, Google, Citizens. These are the guys that make up the backbone of the internet in the old telecom industry. And they are really excited about WebRTC. So in short, I guess we can say that, you know, WebRTC, it is a really big deal. I don't know how many of you have watched the talks from Cascadia.js. It's a front-end developer conference in Canada, where this guy, who's also doing WebRTC, Henrik Jortek, he made a prediction that in 5 years' time, WebRTC will be the leading industry standard for doing voice and video worldwide. So, let me walk you through a bit of the history. Where we come from, when did it start, and where are we headed. So, I won't go through all of this, it's just you want to read what I talk. So in May 2011, Google bought a company that did sort of this RTC stuff and had something working in C++. And they open sourced their C++ library and started working to get a web standard through that could do peer-to-peer networking. In January 2012, WebRTC support hit Chrome developer version, which is sort of Canary, I guess. Developers. Yeah, so that was the first time we could actually play around with WebRTC. It wasn't until December 2012 that it actually hit stable. So then you can actually have, in about 6 weeks' time, most of the users that are on Chrome could actually use WebRTC. But they could only talk to other people that were on Chrome. You didn't have interoperability between Firefox, which had just started having it in their dev version, talking to anyone on Chrome. So in February 2013, we actually had the first call made between Firefox and Chrome, and that was a big, huge milestone. That was the first time you could actually launch commercially viable services on WebRTC. Some guys over at something called Ambiet, they launched actually a competitor to appear in called Conversatio, now Talkie.io. And that was sort of the first commercially viable WebRTC product out there. In June 2013, WebRTC hits Firefox 22, so stable. Finally, you can get it out to users. And we launched in August 2013, and our summer project started in June. We got some mobile support also in August, and in November, Opera as the third browser to support WebRTC launched, which was a huge deal. So the guys over at Anglet, they launched this page here to sort of keep track of the implementations in different browsers. So as you can see, it's pretty red. These were no shot there, but Internet Explorer and Safari are still pretty red. They haven't made any announcements about supporting WebRTC yet. As you can see, Firefox has a bit less support. They don't have screen sharing. And even Chrome doesn't support all the, for example, stream rebroadcasting and echo cancellation is not yet in stable or Canary. So that's still to come. We launched something called isWebRTC-ready.appear.in. That's sort of a browser test. So it stemmed from us having a lot of user complaints about, you don't support my browser, or this doesn't work. So we sort of sent this to them, just, can you tell us what the different, what the answers are here, and sort of copied that to us. And this got really big. We got some attention on Twitter from it. And I think it's the first sort of official WebRTC test. It's not yet in Modernizer, but we're hopefully going to launch it there as well. Okay, I don't really have a reason for showing this picture, but this is the first, it's a really cool picture because this is the first call made on Appearin that showed interoperability between Opera, Chrome, and Firefox. I might have those two mixed up, I'm not sure. But these are the community managers for the respective teams, and they used Appearin to test to see if WebRTC actually worked between those browsers. And when they launched Opera, this was sort of tweeted. We got a lot of attention from that. So now that I've sort of piqued your interest a bit, we can dig into some very simple code to how we actually do this. So how many have tried playing around with WebRTC just at all? Just, fewer than I expected. So the first sort of easy thing you can do with WebRTC is get access to the webcam and audio. So the webcam audio can be streamed directly to a video tag element. It does the VP8 codec, which is supported by most browsers now. These don't support WebRTC. So what you do here is have navigator.getUserMedia. You send in constraints, that's an object. Here we say, we want video and we want audio. Then you get a callback. That callback takes as a parameter local media stream, which is just basically the stream from the webcam. Then you find the video element, and in the source you do create object URL, which is just a special thing you do to get a URL to your stream or a JavaScript object. So when that's done, you actually have the web camera showing in a video element on your page, and you can play around with it. You can use CSS filters and whatever you want. But the real exciting part of WebRTC is actually sending it to someone else. So you do that with RTC peer connection. Now, there's one thing you need to know here, and I've cheated a bit. You need a signaling server. This is sort of the chicken and egg problem, where you want to create a peer-to-peer connection, but to handshake and sort of say that I want a peer-to-peer connection, you need to have a connection. So you use a signaling server to do that initial handshaking. So we use Node and Socket.io to do that kind of stuff, just sending events between the different browsers. And in this code example, I have create signaling channel, which is sort of that. So this is fairly simple. I have a function here called call. It takes a parameter isCaller. WebRTC sort of differentiates between who's calling or not, who's initiating the connection. So you do for sort of the handshaking part of it. But most of the code is the same. So you initialize a new RTC peer connection. You send in configuration. I won't go into details there, but that is a bunch of acronyms actually, different servers and stuff like that, which I need to send in. Talk a bit about that later. And then for the first part here, you have a callback called onIceCandidate. Ice candidates are sort of ways of, and correct me if I'm wrong, Thomas, ways of connecting to another peer. So these are sort of ways to traverse the NAT. It sort of agrees with me. Simplification, I guess. So You can call it ways to connect to the other peer, and when you have those for yourself, you send those candidates to the other party. So what you want to do now is get the local stream. Now we get user media, blah, 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 function stream. We show it to the user himself. We add that stream to the peer connection through add stream. And if it's a caller, we say create offer. And that takes a parameter got description as a function callback. So, and we set something called the local description. And that's, again, a bit off here, that's sort of the capabilities of your own browser and the ways of connecting to you, and sort of I support this codec and stuff like that. And then you send your session description protocol. Again, acronyms everywhere. You send that to the other party. If you're not the caller, you create an answer. And then you take in the remote description for the other peer and the callback function. Oh, I got a notification which apparently lost focus of the presentation. Ah, there we go. Okay, so you then have signaling channel on message. This is just the signaling channel stuff. So if we have a peer connection already, just so you know that we are the caller. If you don't have that, we are obviously not the caller. So then we do the call method, send in false, we're not the caller, and we do the exact same steps as for the answer. We create an answer instead. And then it's just the SDV part, session description. When you get that, you set on the peer connection something called set remote description. And that's if you remember the local description part, which was the sort of description for your own peer, the remote description is for the other peer, the one that you're trying to connect to. So RTC peer connection needs both to be able to connect. So you send the description protocol in there, and then if you get the candidate message, you add ICE candidates to your peer connection. So, when all this is said and done, you will get a stream. You have officially now connected. And then this method here will be called when you actually have the stream from the other party. And then we just do the same thing we did with the local stream, create a object URL with the stream, and you show it. And then you have a peer connection. So you're thinking, wow, that was easy, right? But no, it's not always that easy. I'm going to introduce you to even more acronyms. Sort of, the worst problems are ones you can't solve at all. So you have a lot of browser quirks that you need to work around. And you also have to think about NATs. So I guess everybody knows NAT, right? Hopefully, yes, nods everywhere. So a lot of users are behind NATs. And NATs sort of throw sticks in the wheel. I'm not sure if that is a correct English term. But so they throw sticks in the wheel of your peer connection, right? You can't, it makes it harder to create a peer-to-peer connection because you have a local IP and then you have a public IP and yada, yada, yada. So what you do then is you ask something called a stun server. A stun server will find ways of traversing that NAT for you. So they will create ICE candidates, which in turn will be set on the local description of sort of what ways can I traverse the NAT? What ways can I get around the fact that you are behind a NAT? And sometimes you can't do that on restricted corporate networks, such as Telenor Guest or other, you probably are at work having some really restricted policies. You can't really establish a peer-to-peer connection. It's not possible. So what you have to do then is host something called a turn server. Now turn stands for traversal using relays around NATs. This pink text here is actually a link. It's a link to a Firefox developer page called WebRTC and the Ocean of Acronyms. It is explain everything for you. And if you're going to do WebRTC and have an intelligent conversation with someone else, you kind of need to understand the bits there. I barely understand them myself yet. Here I am. So some as computer first, you need to have a relay server. So you send basically, if you're familiar with Skype and how they use supernodes, this is the same thing, except it's a server you host yourself. You can't do supernodes as of now with WebRTC, like Skype does. So the side fact is that around 20% of peers need turn. This is actual data from our sort of analytics that shows that around 20% of our users needs to use turn. That's actually a bit higher than the world average. Most likely because we are used on more corporate networks because we turn more. But then again, so if you're going to create sort of an appearing clone and you really want to do that, you have to factor in the cost of actually running a turn server which needs to pipe HD stuff between peers, and that can be costly. So now you're probably thinking, this sounds complicated. I'm not really sure if I want to get into all this. But luckily, there's some really helpful fellows. They created something called Simple WebRTC. It's sort of a wrapper around all the browser quirks, all the hard stuff. You still need to host a turn server, but at least it's easier to get it into the sort of protocol. This is a GitHub repo. You go there, you can download the files. They have a signaling server implemented. They have loads of other stuff, so you can get started playing with WebRTC in about 5 minutes. That's kind of cool. So now I'm going to do something a little less technical. I'm going to talk to you about appearing. How many of you have heard about appearing before? Good. Very good. Like, from not reading the description at all. So, yeah. Okay. So I'm going to tell you a bit of how it all started, how we came to be. So with most great things in life, it all begins with the interns. So Komoyo have been doing RTC for a while. We have a product called Talk Plus, which does some RTC stuff. And in that process, you kind of stumbled upon WebRTC. So Thomas, he needed a master thesis proposal. So basically sat down and we got a proposal there, integrate sort of WebRTC with existing telecom stuff from Telenor. So we learned a lot about WebRTC and sort of saw that, okay, this has a lot of potential. And him and Svein, we sort of had, well, we're getting all these summer interns. Why don't we set them to create something with WebRTC? So we sort of sat down and said, okay, let's make them create a video conferencing site. We hate the stuff we have now anyways. It's needed plugins and installs, and it never works anyways. So we can try and see if we can create it ourselves. So sort of, they started with it, and then we have these Friday demos, and 2 weeks later they had an actual working demo. It worked, you can call each other. It was great. Everybody loved it. And now most of the grown-ups were sort of on holiday. So we sort of decided to just productify. Let's just throw it out there, see what happens, see if it sticks. So the domain appear.in.bot. They wrote a quite nice blog post, and we posted it on Hacker News because that's how you launch products nowadays. And it got a lot of attention. Cool. So, I mean, at this point, they have created the logos themselves. It sort of looked, it looked good, but it wasn't sort of what we have now, at least. Had sort of small quirks here and there, but all in all, it was a successful launch. We had 5,000 visitors the first day, and our servers melted. At that time, the Appearin was running on a micronode in Amazon EC2, which, you know, it breaks down if you watch at it, if you look at it the wrong way. And amazingly, a journalist at Liga.no picked up the launch from Hacker News. At least that's what I think he did. So the guy here smiling, that's our boss, or used to be our boss. He's still a boss. He wasn't fired. Still a boss. Just not my boss. He was on vacation and he got a call from Liga, so, hey, we see that you launched this new video conferencing site. Can you tell us a little bit about it? He was like, yeah, that's really cool. I just have to get back to you in 5 minutes. And then he called us and so like, you launched a video conferencing site. That's cool. And it all culminated in this article here. The front page picture is nicer because that's actually of the students themselves, not them smiling. And this got a lot of attention in Norway, and I guess that's where most of you heard about it. No? Okay, so a lot of people heard about it. Our servers melted again. Got it working after a long day and lots of pizza. And we sort of knew that when journalists are starting to contact us for stories, then we are something big, or something at least. So at that point, we decided to quickly establish a team. This is a team. You recognize Ingrid, that's me, that's Thomas, that's Steko, and then we have other guys. Bradley is the server guru, Stig Erland is CSS guru, everything guru, cool guy, and Svein, who's the tech lead. We established a team. We sat down and said, okay, let's establish a proper brand for this. Let's get a proper design. Let's get some resources on it. We launched a bunch of new features. We have chat. We looked at sort of different user segments. Talked to a lot of users. And it sort of worked out okay. A lot of people started picking us up, started using us. We slowly watched the numbers grow. And then I actually don't remember how this happened, but we teamed up with Opera for Opera 18 release, which was kind of cool. It was big for us. Opera 18 was going to have WebRTC support, the third browser, and we contacted them, and they wanted to do a joint thing with us. So that ended in them having us on their sort of release blog, developer blog, talking about us, tweeting a bit about us. We did the same for them. And we made sure that the pairing was working perfectly with Opera once they launched. And this got us a lot of attention again. Users from all over the globe started picking this up. We got contacts from sort of big corporations wanting to talk with us and have consultancy offers, or trying to integrate and can you do this and can you do that. Funny part is they had no idea we were till Nord. So, some clips. This is a Polish website. That's the whiteboard we had previously, which we had to remove, unfortunately. Might make a good return. This is a Mexican website talking about the period. Tech blog. This one is really cool. This is from a radio broadcast from a podcast show, a gaming-focused podcast show called Splumatic. They use appearing to talk to their listeners during their broadcast. So they were sort of saying, welcome to appear.in/Splumatic. We'll talk to you, we have you on the show. And it worked great. They actually got some users. I talked to them and interacted. This guy is apparently a big sort of, lacks a bit of text there. This is a big French tech blogger, and we got a lot of attention from him. He wrote an amazing review for our service. We quadrupled the previous record for number of visitors in a day, and our service did melt. Yay! That's kind of good. This is an Arabic webpage. Have you translated this yet? I'm not really sure. But it's kind of cool. You see users from all over the world. So right now, Appear is used in 197 countries. And when you say that number, you start asking yourself, how many countries are there? And we went to Wikipedia, which is a reliable source for everything. The list of sovereign countries is 206. The United States only recognizes 197 countries itself. So you can safely say that we are used globally right now. You can see that France is really big, Norway and the States are big. And currently, as of this morning, we had 34,112 rooms used. And it's still counting. We are still getting lots of new users. I think we had 300 or 400 new rooms just in a day. And a lot of those rooms are used often. So I think we and sort of the whole WebRTC movement is onto something. You see competing services having similar numbers. You're really onto something here. So let's get back to a bit technical stuff. How does all of this work? Now, I've cheated a bit on this slide. I took a screenshot of the thing, so you have sort of that's not a spelling error, I think. I couldn't be bothered doing that late last night when I finished this. So we have our signaling server, and we do signaling there, and audio video goes to the peers themselves. Our backend is built entirely in Node.js. We use Express for the HTTP part, and we use Socket.io for our signaling. The entire thing is running on Amazon EC2, a medium instance now, and we have only one instance. We are not currently looking at having more instances, but we will in the future. The entire server is stateless. We keep all state in Redis on Elasticache. Well, when the first version of Appearing, when you restarted the server, you lost all data. Everything was stored in memory. We actually push static assets from that same node right now, and that's 90% of our load, I suspect. So once we manage to move that over to CloudFront, sort of a CDN service, we expect the load to go down a bit, and we can postpone moving it to different instances. The front end, I guess this is the Google Developer Meetup. I guess most of you know about AngularJS. Hands up. A lot of you know about AngularJS. It's a front-end JavaScript framework. Works great. We use that to sort of build the pages. But to be honest, most of the stuff we have is custom built. The RTC stuff is entirely custom built. That's mostly the interns and a little bit from us. I built that. We didn't want to use simple WebRTC. Then we wanted to have more control of the nitty-gritty parts. And sort of from our technology choices, we can have sort of freedom. So since we only support Firefox 22 and above and Chrome something and above, only the two last browser versions, we can experiment with all the new cool web technologies. We use Flexbox for CSS, sort of to do layouts and stuff. We can play around with filters, and sort of all the new stuff that gets out. We will probably start looking at web components when that lands properly and stable and has operability within browsers we use. We use that. And at the same time, this demands a lot from the team. Because we have to stay on top of what's new in the world of WebRTC, what's new in CSS, what's new in JavaScript, what can we use, what can make our job simpler. But it also makes us able to iterate and work even faster. So we don't have to spend a week trying to get file uploads working in Internet Explorer 8. Awesome. So our mantra there is sort of 60% of will. That's good enough. For us, it makes us able to move extremely quickly. We don't think that if we had a Flash plugin to do the WebRTC stuff as a fallback, we would be able to work as fast as we do now. And so when a new feature comes out, it's only about 6 weeks until we can start playing with it. And that's really cool. Let's move on to sort of how do we work. We use GitHub. We use GitHub issues to track sort of the tasks we're supposed to do. We use pull requests as code reviews. Pull requests for code reviews is a bit limiting. You don't have two-way split and stuff like that. But for us, it means that we have less friction when we actually want to just get stuff through. We also have a mantra of we push everything to master. So when we have a new feature, even though it's not completely ready, we push it, we feature flag it, and it's in master and it's deployed. So that way we can test stuff on the web page itself by just adding a couple of feature flags. Just to see it working in production, we can send out emails to a limited set of users and make them test out new features for us. I also wanted to plug something called waffle.io. Not sure how many have used that, but it's sort of a, I call it Scrum board or Kanban board, or I actually don't know the right terminology for it, but you're familiar with this, lanes, swim lanes, ready. And you connect with your GitHub account, you choose the project you want to watch, gets all the issues and allows you to move them over and keep track of what you're working on. So sort of the most important thing about how we work is that we talk to users. We talk to users a lot. This image here is from Ingrid and Andreas went to UiO to talk to some students. So we didn't have sort of an appointment or anything. We sat down in the cafe. They put up this sign, we'll buy you coffee if you use 50 minutes to test our new product for video chat. And it worked. People got over. They get to buy fancy coffee. We get to have their feedback. They try around stuff. And we got a lot of helpful feedback from that. We also, the most prominent button in a room is the feedback button. So we get a lot of feedback on emails, and we try our best to answer emails personally, have a personal feedback to everyone, and we try to answer all of it. The entire team participates in that. We just send a reply, I'm answering now, so we don't, we have accidentally answered within a few seconds of each other, but it rarely doesn't happen. And we are going to try to follow that model as long as we can. We know that it doesn't scale and all that stuff, but for now it's really helpful for even the developers to understand how do users use the product, what pain points are there, and we get a lot of positive feedback as well, which is inspiring. We do 1 week sprints. We have a planning meeting for 1 hour every Monday where we discuss what we're going to focus on this week based on user feedback and based on what we think is good. We do rather than plan, instead of sort of trying to plan features down to the minute details and user tests and all that stuff. We have found that if you just start implementing it, if you have a prototype up and going, up and working, we push out in production, we feature flag it, and we go out and we test it. I mean, it's sort of easier to find the sort of the pain points or the things that doesn't work when you actually have a live working demo of it. And because we don't have to do all the different support for it, it's easier to get features out. Chat was, I think, 3 days of work to get it out. We launched it, we pushed it out to users, we got a lot of feedback. It took us 1 day to fix the pain points, and now it's working sort of nice. Cool. We do analytics. We don't have a big data team behind us. We don't have a Hadoop cluster. We use tools that are available to us now. So we use Kissmetrics and Google Analytics. For Google Analytics, we sort of do it for getting the broad overview. How many visitors do we have? What's the conversion rate? We use Google Analytics to do experiments, A/B testing. They can actually do that now. It's kind of nice. And then we use Kissmetrics to sort of deep dive into single users. So we know that there are some rooms that are very active, so you can sort of look at how they are used, or look at users that are done a specific task, and look at how they navigate through the page. We can also do more advanced analytics there, sort of funnel reports or cohort reports, to sort of see our conversion rates in more detailed manner than we can in Google Analytics. So, where do we go from here? Well, our first priority is get buttloads of users. We have no plans of making this, we have no plans of taking payment for it, or any of that. We are sort of looking at the freemium model. We want the product to always work, sort of the base features. So what we have now, going to a link, seeing each other, having as many participants as you want. We want that to always be free. And then sort of, for the advanced users, those that require more, we can sort of look at ways to get payment from that. We have no intention of introducing login concepts or registrations. So it's surprisingly hard to think about how you're going to solve the different issues when you don't have logins. We also want to drive development of WebRTC with the different browser vendors. So we make feature requests, we do bug reports, we participate in online discussions. We try our best to help the WebRTC community move forwards. We have contacts in all browser camps at the moment, so we can sort of hear what they're thinking about it. And for that, as Telenor Digital, we know that WebRTC is going to be fairly big, and a video conferencing site is not all that WebRTC can be. So by helping to drive the development of it, we can sort of help them focus on the stuff, on creating, like you guys can create even better services. We need better mobile support. Right now, if you use Appearing on an Android phone, you will actually manage to drain the battery faster than you can charge it from a USB port in your computer, which makes debugging on a laptop really hard, because you set it on and suddenly, oh, I don't have battery left. It's okay, I can't use it anymore. Most phones today don't have DP8 decoding or encoding in hardware. DP8 is sort of the de facto standard for codecs right now. The WebRTC consortium, the guys that decide all this, have not landed on a standard codec for everything. Cisco recently made free something, H.264 as a binary, so you can use that in applications, hopefully to push browser vendors to implement H.264, and that has much better mobile support. That has hardware acceleration on mobile phones. We are sort of also playing with the idea of implementing native apps and doing stuff like that, but nothing is decided yet. We also need better retention mechanisms. So we don't have logins. Our users can technically go to, at the moment, any other page and do almost exactly the same thing. We need a way for users to invest time in us, while still not going away from the no login principle. We don't want to nag users. We want them to choose us because we have the best service. And most important of all, we're going to continue creating a kick-ass service for our users. That's sort of my part of the talk. We have one more thing. That's from Kjetil's part.
That's me. So if you would like to get something to drink while I set up things, you can do that. I'll be quick.
Det var avfrågan. Ska det funka? Magisk?
Så tog jag från min ring och bara, nej.
Nej, det är inte. Technical problems.
Demo Ghost.
Demo Ghost. Perhaps consider drinking and more sushi. Ta forskning.
Yes. That will work. So, hi, I'm TK, also work at the Appearance team. What I'm going to do now is, well, I'm going to show this site once again that Dag-Inge just showed you, which we made to check browser support for WebRTC. So here you see Chrome, and here you see, well, Safari, which does not really support that much. So what we then thought we would do is implement a small thing that everybody, you developers, can implement on your site to check your browser's support. Where is my Windows? Dual screen on Macs, guys. It was there somewhere. Here it is, yay. So, let's see here if I got it. Wrong demo. My Windows got lost. Okay, let's just do this one up. So, yeah, this is my new and completely new and original idea, which I'm gonna recreate a chat roulette with our new API. So what I'm gonna do now is just check if the browser support WebRTC by appending a support thing right here. So what I'm gonna do here, can everybody see this? See if I can make it a bit larger. There we are. It's better. Yeah. So first of all, I'm just gonna include our API through a regular script that I'm downloading from our server, which then will let me do simple API calls to our WebRTC ready.appear.in. Then I can just appear in ready, which then will just get that simple callback containing some data. Let's see if this works. Did I misspell it once again? API dot is compatible, of course. It's appearing compatible, which then will return some useful data about the browser you are in. Here we are. Once again, very, very let's see, the data we just received will then tell me if it's supported and all the tests that it ran. So what can you do with this data? Well, then you can simply present to the client different UIs depending on whether your browser support WebRTC or not. Then I'm gonna try to recreate this here while I'm standing here. What we're gonna do is just have this button here work by sending a small signal to a signaling server that I want to talk to somebody random. And because every single string that you can think of works in a room, appearing / anything will create a room, is kind of an API we can use. So I'm going to try to do that. By when the server receives a get pairing call, which is what the button does through some socket.io magic, it will then try to set up a connection between anybody who's in a queue on the server. So what I'm then going to do when the socket gets socket gets the get pairing call, you will then say that the client is searching true, and then the client will searching for partner. Then we need to check the queue if there's anybody in the queue, which is just done by if the pairing pool is not empty, do something. If it is empty, we'll just have to wait patiently. Wait patiently for another partner to try to connect to you instead. So if the pairing pool is not empty, we can then try to make a pair. The pair is, well, simply a small array of participants. Then we need a client to connect to, which we will fetch from the pairing pool. If anyone of you know JavaScript, you will get this. If you don't know JavaScript, this is strange. It's strange even to me. You have to splice the array, then you need to find a random position in the array, which is math random times the length of the array. Pairing pool length -1 because 0 indexing. You have to round that to actually get some valuable data out of it, and this returns an array, so we have to get the first element. Is this correct? Yeah, it looks like it. Now you have pair. You have the client itself. Oops. The client itself and the random client that you're trying to reconnect to. Okay, then what you need then is an appearing room that you can talk to each other in. And as I said, any string will do, so we can do this. Equals Google developer group Oslo. But that's not that fun. Everybody's trying to use the service will end up in one Google developer group Oslo room, which is not exactly what we want. We want to get random room name, because a random room name of sufficient length will be statistically unique. Not guaranteed, but any sufficient length it will actually be random or unique and empty. So get random room name will then be a function that returns a room name. Actually call it name because the reasons name is then start off with an empty string, which will then populate with a set of letters. How long do we want it? We could be 40 characters. Should be enough for now. We then also need an alphabet to get characters from. Any letter will do, so we'll just populate this with stuff. And then we'll again do the lookup using the math random times the length of the alphabet -1, which then will return a random character from the alphabet that we chose. and we just do name plus equals to that character, so it will do that 40 times, resulting in a huge string that can be used as a room name for them to share. And then we just need to prepend this with some appearing URL stuff, which then will result in a URL string that you can enter. For it to look a bit prettier, we have a light version without that many UI things that is better for embedding. So when this has returned a room name, you then need to just add the pair to the pairs that is stored. Pairs, we store that on the room name. Pair. And then after you have registered the pair sufficiently, you need to signal to each of the clients in the pair, which is then just pair dot for each client in the pair, you then set as they are is searching, no more. They are not, they are actually in a room. And they are in the room that we just created. Then we need to send this data back to the client using the sockets that we have, socket.emit, that they have been paired. They are going to meet in the room name. This will then send to both of the clients that, yeah, we found match for both of you, and we're going to send you to this room. The actual front-end stuff is very simple. It's simple header stuff, buttons and stuff, and a simple iframe that is embedded with the height and width, resulting in, let's see if I can find a new browser. I cheated a bit because I'm not confident it will work always. It will result in this. We will make a few more tabs of this. So 3 participants, you talk to some random, he's searching, and they found a match, they found each other, and we have 2 pictures of me shortly. No, the camera doesn't work, it never works. But yeah, so now we actually have a working Chapter clone. And this is with minimal effort on my side. So everybody here, if you have a nice, good idea, can actually use what I've just shown you here today. It's available. You can embed appearing rooms in context you find a bit more, well, child-friendly than maybe Appearlet. Actually, I do have another example of what we've built as an example. Appearing.github.com GitHub, which then is your GitHub-ish place where you present and discuss your source code. Here is some random code from your pull request with a hash and everything. People discussing that. We'll actually size it up a bit. And then we have a set of watchers on the task. And here you can talk live about the pull request, which is then here supposed to be an embedded version of Appearing, but I think the browser is hanged right now. Sorry about that. But here it has generated, as you can see, room name based on the hash of the pull request, the commit, which then the participants and the watchers that is interested in the task can, well, when they feel obliged to talk about the pull request. Yeah, so that's the Appearing API. It's undergoing heavy development at the moment, and we are gonna include some more functions. One function that is gonna be shortly is creating a unique, truly unique room name. Maybe a bit more sexy than what you'll get with your generic random room generator. Yeah, and we are taking a lot of requests for this API. We have no idea what to put in it at the moment, so please give us some feedback on the API. Yeah.
We have time for some questions, I think. We have prizes, so ask questions. We have gloves that you can use on your smartphone. Awesome. I use them every day. So whoever asks a question, please ask a question. Hey, at the back.
I was wondering, could this be used for like having lectures at universities with a lot of people connecting at the same time?
We have set a limit at 8 people per connection at the moment. It's not a hard limit. You can actually connect with as many as you, or attempt to connect with as many clients as you want to.
The main problem is